simple. This topic simple so that you'll be able to solve when you're alone. Now, about mathematical induction, there are only three things which I want you to understand. Only about three things, three important things I want you to understand. The first thing is simply the basic step. Okay, so the first thing is called the basic step. Under the basic step, what exactly are we looking for there, or what's there? Under the basic step, that is where you make your n equal to 1. Okay? That is where you make your n equal to 1. And you must be able to prove that actually your right hand side must equal to your left hand side. You must be able to prove that. Okay? The second step is called the induction step. The second step is called the induction step. Now, under the induction step, this is simply where you have to make your n equal to k. This is where you make your n equal to k. And you must assume that this theorem where n is equal to k is true. Okay? You must assume that you assume it is true. The third step is simply where you have to make your n is equal to k plus 1. So third step is simply where you make your n equal to k. So the third step is where you make your n is equal to k plus 1. Now these steps are going to guide us and give us a clear picture on how to answer mathematical induction. So mathematical induction is simply all about trying to prove if a certain flow of numbers is actually true or real. Okay? That is all about this particular topic, and that is what I want you to understand as I start teaching. A very good example we are going to look at different questions. Have you copied this? Can I rub so that we start solving? We do some questions, then I give you go and solve in your tutorial sheets and stuff. Is it okay? Can we start? Can I rub the 3 steps? Can I rub the 3 steps? Okay. So we rub the 3 steps. Then we say practice questions. Practice questions. Just those 3 steps and you are good to go under this topic. So we have a question which is simply saying prove by induction that 1 plus 3 plus 5, then there's a plus dot, then there's a plus 2n minus 1 is equal to n to the power 2. So now, how do we prove this question? It's very simple. The first thing to do is simply to let your n equal to 1. Is there anyone who is able to unmute themselves so that we solve together? Anyone who can unmute them, him or herself, we solve together? Are you there? Are you there?
Yes.
Who is that one?
Shona.
All right. So, what was the first step? The first step, what was it saying? We make what?
N equals to K.
Huh?
N equals to K.
That was the first step. That's what I said. Who wrote the first step?
The first step is that n is equal to 1.
Okay, you're the same one who is from talking right now. Let's go. The other one, you mute your microphone. Okay, so the first step is we let n is equal to what?
1.
1. Okay. Then you say right hand.
Then
No, it's okay. I've gotten you. Then we say left hand side. Then you say right hand side. Then left hand side, you have this part here. You can mute yourself. It's making a bit of some noise. I'll be telling you when to unmute. So left hand side, you have that part. So you can write it here. You say so you write. You say 2n minus 1. Okay. Left side. Then right side, you have this part. This is n to the power 2. Then since you had said n must equal 1, so you put your 1 here. Then you also put your 1 here. This is going to be 2 minus 1 equal to 1. Then 1 to the power 2 is going to equal to 1. So is the left hand side and the right hand side the same? Are they the same?
yes,
So they are the same. So when you reach at this stage, you discover that they are the same. It's telling you that you need to proceed and ensure you prove the last part. Okay? You prove the last part. So I can write this here. I can say right hand side. Here you had n equal to the power 2. You put your 1 there. You are getting 1 here. So let's try to wrap that part. We create more space. You see what I'm going to do. What is the second step telling us?
we write the entire equation starting from 1 up to the end. Then since we say the second step would be n is equal to k. So we substitute where there is n by putting k.
So the second step is simply we say let n is equal to k. Okay? Let n is equal to k. So you rewrite the whole thing. Like she has said, 1 plus 3 plus 5 plus dash dash dash. Then you say plus. While there is n, you will be replacing with k. Okay? So this is going to be 2k minus 1, then equal to, then you say k power 2. Then you can write this one as equation 1. Have you seen what I've done? You write that one as equation 1. Third step, what is it saying? Third step. Third step.
Third step, we let n equal to k plus 1.
So, the third step, we say let n equal to k plus 1. Now here, this is where I want you to listen. Okay? This is where I want you to listen a lot. You are going to get the original equation, which is here. So the equation 1. So let me draw it here. If you just understand this concept, you can solve every other thing. So you say 1 plus 3 plus 5, then plus, right? Then you say plus. Then the same way it is this equation, you write it down. You write it, this part you write it the same way it is. So I'm going to write it the same way it is. Then from the original equation, I'm going to get this part. From the original equation, this is the original thing. This is the original equation. Okay? From equation 1, which is here, you add this part. Okay? Now, when adding this part, where there is n, you'll be putting what? This part. So, this is going to be k plus 1. Like that. Then you say plus 1. Okay? Like that. Then you say equal to. Then here, where there is n, you replace with this guy here again. Forget this part. Only replace this where there is n. So because there it's n to the power 2, me I'm going to say k plus 1 to the power 2. Okay, then from here, you know that from this part here, this part here is the same as this one. And it was equal to k to the power 2. So this whole part that I've lined here, you replace with k to the power 2 plus 2. Yes.
Yes, here where it's written k plus. That means here on the second step where n was equal to k, we had 2k minus 1. Now here on the third step, whereby we first rewrite the one for the second, which is 2k minus 1, then plus 2, we get, since we are letting n be equal to k plus 1. Here where we've written plus positive, is it not supposed to be negative?
Yeah, it's a minus. I've just said it's just a mistake. It's just an error. It's a minus.
Alright.
This one is a minus because there is a minus. I'm just replacing where there is k. I'm replacing with this. Then following the order is a minus, yes. Okay. So now, from here, you expand your thing. Okay. So this is going to be 2 multiplied by k is going to be 2k. 2 multiplied by 1 it's going to be 2. Then minus 1. Then this is going to equal to, this is just the same as you're expanding things. You're just trying to expand your things like that. So this is going to be k power 2. And then you're going to say plus, this is going to be 2k. And then this is going to be plus 1. Okay, 2k plus 1 equal to k multiplied by k is going to be k power 2. K multiplied by 1 is going to be plus k. K multiplied 1 multiplied by k is going to be k. 1 multiplied by 1 is 1. So you're going to discover that you're going to have k power 2 plus 2k plus 1 equal to, then this side you're going to have 2k to the power 2 plus k is going to be 2k, then plus 1. You discover that right hand side and left hand side are the same. Therefore, conclusion, you can say, since the left hand side is equal to right hand side, okay, the math statement is actually correct. Okay, this is the part that I just wanted to add. Since left hand side is equal to right hand side, the math statement above is correct. Clear? Clear? Okay, so that is how we prove inductions. I'll be using the same concept to do the next one. I'll be using the same concept to do the next one again. This one is saying we prove by induction that okay, this one is supposed to be 1 plus 2 plus 3 plus, then you say plus n is equal to, then you say n here, and then you say n plus 1, then you say over 2. We prove by induction that 1 plus 2 plus 3 dash 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 plus n is equal to n, then open bracket n plus 1 over 2. So the first thing that we're going to do, of course, we're going to write our solution. We are going to follow the same steps we're using. The first one is simply to let n is equal to 1. Then we say right hand side. The right hand side, what we have is n. Okay, that is this is left hand side, right hand side. So this is going to be n, then n plus 1. So while there is n, I'm going to replace with 1. Then I'm going to replace 1 there, plus 2. So plus 1 over 2. So this is going to be 1, 2 inside over 2. So this and that will cancel. We're going to remain with a 1 here. Then you say left hand side. Left hand side, what do you have? You have n. So while there is n, you replace with your 1. You discover that the left hand side is equal to the right hand side, which entails you to proceed. The next step is where you say you let your n is equal to k. Then you write the same equation, original. This is going to be 1 plus 2 plus 3, then dash 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 dash. While there is n, In fact, state that this one is the original equation.
Sir, sorry for disturbing. Just to get back here, what is 1 open brackets 1 plus 2 over 2? Why aren't you adding 1 plus 2? You get 3, but you're canceling the 2.
Which 1 plus 2 is here, Moranti?
Why you're proving from the what is the right hand side?
This is not 2. I mentioned that this is 1.
Alright, not good. I saw it too there, that's why I was.
No, it wasn't. I mentioned that that is not 2. That is 1. Then you rewrite everything. Where there is n, you are going to replace with k. Then even this side, you are going to replace with k. Even this side, k. Over 2. I'm very slow today because I want you to understand this topic. It's very simple. When you reach here, you make your final theorem, the third one. You name this one equation 1. Then you say, you let your n is equal to k plus 1. Then you rewrite the whole thing. One plus 2 plus 3 plus, where there is this k, you write it t originally the way it is. That's what I mentioned. That's what we did at first. You check the time we're writing this equation, this part here we maintained it. It's here, we maintained it. Even here, this part here will be maintained. Then what did we do? We added plus, then went to the original equation, this part. But where there is n, we are replacing with k plus 1. So even there, that's what we are going to do. So we say plus, then we get the original part, which is this n. Where there is n, we said we are replacing with this. So I'm going to replace k plus 1. Then I say equal to, where there is n there, I'll replace. I'll use the original equation, which is here. Okay? I won't use this. I'll use that. Even here, that's what we did. We are not using this. We are using this, the original equation. So, you get your original equation where there is n. You replace with k plus 1. Even inside, you're going to replace with k plus 1. Plus 1. Then over 2. From this part here to this part, we know that we found this. So I'm going to replace. This is going to be k, then k plus 1 over 2 plus this part here, k plus 1 equal to k plus 1. Then inside, this is going to be k plus 1 plus 1. This is going to be k plus 2 over 2. When you reach here, what do you do? So this one is just the same as everything is covering up because it's multiplication here. When you reach here, you discover that This is the denominator of 2. The denominator of 2. So what can you do? You can say k over k plus 1 over 2, right? Then you say plus, then you're going to say 2 k plus 1 over 2. It's one and the same, right? Is it one and the same? Yes, it's one and the same. Equal to, then this is going to be k plus 1, then k plus 2 over 2. Then you can cancel out everything now. So when you cancel out those guys there, are going to remain with k plus 1.
Sir, I can't see what's on the screen.
So this is going to be k plus 1, then plus 2, then k plus 1. Then this is going to equal to,
Sir, I can't see what's on the screen.
who is that one?
Charles.
It's not me. It's it's the network. Log out and log in.
All right, now I can see.
So this is going to be k plus 1. Then this is going to be k plus 2. Then we expand. Please make sure you expand everything. So this is going to be k multiplied by k, it's going to be k power 2. K multiplied by 1, it's going to be k. 2 multiplied by k is going to be 2k. 2 multiplied by 1 is going to be 2. K multiplied by k is going to be k squared. K multiplied by 2 is going to be 2k. 1 multiplied by k is going to be k. 1 multiplied by 2 is going to be 2. So this is going to be k power 2 plus 3k plus 2 is equal to k power 2 plus 3k plus 2. Since right hand side is equal to left hand side, mathematical statement above is true. Over. That's how simple induction is. That's how interesting induction is. Hello? Thumbs up if you have understood. Thumbs up, thumbs up, thumbs up. If it's clear. Should be able to solve questions on this topic. These are simple topics, simple concepts I'm giving. Let's do another one. The third one is saying, prove by induction. Prove by induction that 1 over, I don't know if this is 1.2 or it's 1 multiplied by 2 in that data sheet. And then you have 1 over 2.3 plus 1 over 3.4, blah 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 blah. Then we say plus 1 over, then n plus 1, they say is equal to n over n plus 1. Solution. I won't change the concepts, I will keep the concepts. The first concept was let n is equal to 1. Left hand side, what we have is this part. So I'm going to write it there. 1 over n, then n plus 1. This is going to be 1. 1 plus 1. Then this is going to be 2. Down there. Right hand side, we have n over n plus 1. So it's going to be 1 on top. I'm going to put 1 there where there is n. So I'm going to get 1 over 2. From here, I mentioned your statement is already showing some truth. So next step, you let your n is equal to k. So you're going to copy the whole thing.
Sir, n is 1 over 2. It's a half, it is not 1. Or it's not mandatory like n is supposed to be 1.
N is supposed to be
Is it
equal, yes, n is supposed to be 1.
Oh, sir, our answer is 1 over 2. Is 1 over 2.
Your answer is what?
The answer that you've gotten there is
Yes.
1 over 2. Means n is not equal to 1.
Who is this one?
Well, it's 1. It's fake.
Huh?
It's fake, sir. We're saying we're letting n to go to 1. Meaning the answer we're going to get after substituting on our equation is supposed to be 1. But when we substituted on our equation, we are finding a half. Now that's why I was asking to say, is half the same as 1? Are we not supposed to try another number?
Who can answer her? Can someone just answer her? Someone to answer her. Are we solving for the value of n?
No.
We can answer, sir. Now we can't see the screen.
Are we solving for the value of n, or we're just trying to prove the right and the left hand side by making n equal to 1? Is that not what the concept says?
Oh, alright, so I get it now. But I thought, what I thought was that the answers that are supposed to be getting, they're supposed to be always 1, since we're trying to prove it n is equals to 1. So I thought our answers that will always be getting it to 1.
So you are saying you want to replace what there is n, you replace with 1 over 2.
No, sir, they are the answer that we got. When we are going to say 1, this is 1 over 1 plus 1, meaning it's 1 over 1 over 2. That's all. I have to add the numbers that way down.
Yes, so now 1 over 2 Your 1 over 2, to you, it's the value of n.
From what I've calculated.
I'm saying 1 over 2
From what
is... I'm saying 1 over 2 is the value of n to you.
yes.
How is 1 over 2 the value of n? Are we solving for the
So
value of n?
now, what I thought was that the answers that will be
Okay,
getting,
what you are
it
thinking
will
is
be
wrong.
all.
What you are thinking is wrong.
Yes, that's what you're just supposed to say, sir. Thank you.
What you are thinking is wrong.
Not sure.
So the reason why I'm saying, you are look.
Also, me, I think I'm behind on this one because I said they said n should be equal to 1. How come it's half?
My guys,
Guys,
we are replacing
what is
where there
happening
is
here?
n, we put 1. Where there is n, we put 1. Then we prove to say we have the same. We need to have the same answer. Right hand side, we need to have the same answer to the left hand side. I don't know how I can explain this. It's not that we need to have answer to be 1.
This is very simple, like she has explained, guys. You guys, but you were not there the time I started explaining this.
All right, so we get the point now.
Hey, hey.
Thank you, sir. For getting it. So is it to do like that?
Eh, it's to do like that because me, I don't understand what you are saying, you. Hmm? Ah,
Because the type entered the network was bad.
no,
So
no,
we're
no, no, no,
unable
no, no.
to get.
Ah, ah, ah. That is end stage. End stage. You know what end stage means? Mulasti mwanche, whereby you're not thinking. Hmm? You're drowning. I said the concepts, there are 3 steps to understand that you should know. The first one, your n should equal to 1. Your second one, your n should equal to k. The third one, your n should equal to k plus 1. For the first one, you are just proving. You are not finding the value of n. You are not finding the value of n. The value of n, you have already said, let n equal to 1. The value of n is already 1. You are just getting this part here, which is on the left side, and replace 1. That's all. And you find your 1 over 2. Someone wants to put 1 over 2 here and say it's not equal to 1. If you did this, you're not doing fine. You get your right hand side here. You put 1 over 1 plus 1 equal to 1 over 2. Then ngatwami karipira atibara karipira. But see what you're doing there. Can someone tell us, the two of you, thank you for wasting my time. Can someone tell us the next step that we are supposed to use?
No, sir.
The next step we're supposed to use is what? N must equal what? K. You get your original equation, you rewrite it. I'm going to, the same way I solved that one. It's the same way I'll solve. It's the same way you'll be solving all the questions. I'll replace 1.2 plus 1 over 2.3 plus 1 over 3.4. Then where there is this guy here, I replace with k. It's going to be 1 over k. Then k plus 1 here. Then you say equal to, then you have this part here. You replace k again. K, then k plus 1. Then you can label it as equation 1. Okay, let me ask you, is it clear up to this level?
Clear.
Then when you reach here, I want to be slow. What do you do? When you reach there, you are going to rewrite it. So definitely like what we did. 1 over 1.2 plus 1 over 2.3 plus 1 over 3.4 plus, I said you maintain the first thing. First you maintain. So I'm going to maintain. The one I'm going to write in this color is what I've maintained. So it's going to be 1. It's going to be 1 over, this is going to be k, then k plus 1. Okay. Then I say plus. Then I'm going to get the original, this one. But this time around, where there is n, I'll be putting in k plus 1. So, one over k plus 1. Where there is this n, I'll replace with k plus 1. Then plus 1. Okay, that n there, then we say plus 1. Like that. Then we say equal to, there we have n on top, which is here. I replace with the k plus 1. Even here where there is this n, I'll replace with k plus 1, then plus 1. When I reach here, this whole part from this area to this area is this one. It's this one there. So you are going to replace it. You are going to say k over k plus 1. This whole area here, we know what we're doing, is k plus 1. Then you say plus 1 over, then you're going to have k plus 1. Then this is going to be k. Then this is going to be 1 plus 1, which is going to be 2. Then this is going to equal to k plus 1 over, this is going to be k. Remember, this is 1 plus 1. This one here plus this one here is going to be k plus 2. I want to do some gymnastic which I did on top. Sorry, a gymnastic which I did when we just started. That's the one I'm going to use here. Let me use it. So, okay, just a minute, let me just rub something. Okay, it's okay. So, we have this part. I just want to rewrite everything. This is k over k plus 1 plus 1 over k plus 1 k plus 2 there is equal to k plus 1 over k plus 2. Guys, can someone tell me which one is a common denominator which is appearing on both the right hand side and left hand side? A common denominator which is appearing on both the right hand side and the left hand side. A common denominator which is appearing on both the right and the left hand side. I want to teach you something here. Let someone answer so that we make the mistake together, or I correct you. A common denominator which is appearing on both the left and the right hand side.
Common denominator is k plus 1.
Okay. Someone is saying k plus 1. I mean the common denominator which is appearing on both sides. A common denominator is appearing on the left hand side. So just checking the denominator, which one is appearing consecutively? Left hand side and right hand side.
It's
K plus 1. K plus 1.
Mwanchon, nani wasko? That was k plus 1.
it's k plus 2.
It's k plus 2. Because you have a k plus 2 is here. Even this side is there. Okay. So, what does this imply? It implies that you need to replace k plus 2 where it's missing, just like I did part 2. You remember what I did Pamoro part 2? Somewhere, Nyapa, let me show you. There's somewhere where I used something. Is it okay? You remember what I did here? This part here. That's what I'm going to do even there. I'm going to say k plus 2 on top. Then even here, I'll say, so this k plus 2, then I'll say k. Then here I'll say k plus 2, because I know when they cancel, they make 1, right? It's one and the same thing. Then here I'm going to replace k plus 1. Then this is k plus 1, k plus 2. This is k plus 1, k plus 2. Now, when you reach here, what do? Cancel out all the k plus 2 because you have them everywhere. What you do here, you also do here. When you do that, you're going to remain with k plus 2, then k over k plus 1 plus 1 over k plus 1 equal to k plus 1 over 1. The common denominator this side is simply k plus 1. K plus 1 into K plus 1 is 1. 1 multiplied by what is on top, it's K plus 2, then K. Then this is going to be 1, and this is going to be equal to K plus 1 over 1. Then you cross multiply. So it implies you're going to have K plus 2, then K here, plus 1 is equal to K plus 1 there, K plus 1 there. K multiplied by K it's going to become K power 2 plus 2 multiplied by K, it becomes 2K plus 1. K multiplied by K, K squared, K multiplied by 1, K, 1 multiplied by K, K, K multiplied by 1, 1. So final answer, we're going to have K squared plus 2K plus 1 is equal to K squared plus 2K plus 1. Since left hand side is equal to right hand side, mathematical statement above is correct. Simple. Hello, is it clear?
It is, sir.
I wanted to teach the other segment of this same topic. Now I'm tired. Remember, I said we'll be solving many questions, so I wanted to add that second part and also partial fractions. But because of what is, because I had the program for myself,